In this video, we're going to do a few more examples of the chemical reactions that we just learned for alkenes, the addition reactions. And this is just to give you some extra practice and see some more examples. So let's walk through these together, and then the next set I will let you pause and try on your own. So here, if I look at the 2 carbons of the double bond, the one up top does have 2 hydrogens. The one on the bottom has none. I'm going to redraw the structure without the double bond, showing those hydrogens. Remembering these are the 2 carbons that I'm working with. This is symmetrical, so I actually don't need to think about Markovnikov's rule or care where those hydrogens are, but I'm going to add a bromine to the top one and a bromine to the bottom one. Clean this up and redraw it. And there's the final structure. Second one is a hydrogenation. I'm adding H2. Again, it's symmetrical. With hydrogenation, you really are essentially erasing the double bond. So this is what the product would look like, the alkane. For the last example, it's hydration. So this is asymmetrical. One carbon is going to get a hydrogen. The other one is going to get OH. So I do need to think about what's currently attached. The first carbon has 2 hydrogens. The other one of the double bond has none. So redraw the structure without the double bond. These are my 2 carbons I'm working with. The carbon that already has more hydrogens, which is the one on the end, is going to get the new hydrogen. And then the other carbon will get the other half of the molecule, which in this case is OH. So again, redraw the structure. And that would be the final answer. Here are a couple more. Go ahead and pause the video and see if you can come up with the products. One comment on the first example, notice there are 2 double bonds. Whenever you've got reactions written this way, you'll assume you have as much of the other reagent as you need, unless it tells you you only have 1 molecule or 1 mole of it. So in this case, that HBr is going to add to both double bonds. All right, here are your answers. The top one, bromine, is going to add to both of the more substituted carbons, so the ones with the methyl groups, and then hydrogens add to the other carbons of the double bond. This last example, whenever you're thinking about Markovnikov's rule, you'll see that there's no difference in substitution for the 2 carbons. Both of them have 1 hydrogen. So what will happen is you will actually get a mixture of products. The chlorine will add to both carbons equally, so you can get it to add to the carbon on the left or the right, and you'll get 2 different structures.